aren't on our subcommittee attending today. We're looking as a CRJC subcommittee for Mount Ascutney's region to offer different guests, speakers on various topics that as a group we try and take back to our towns and help generally educate people about the river and all the issues around the river. My name is Nancy Heatley. I'm the chair of the Mount Ascutney subcommittee, and our group represents a number of towns on both sides of the river, which makes it slightly different compared to some of the other groups that work on river issues. And so we are typically when the issues we work on anything obviously to do with water quality, with riparian buffers, with working with other towns for projects such as a septic smart seminar that we offer every year. And you'd be surprised how many people will spend 2.5 hours at a septic smart seminar on a Saturday. We get
in September.
In September, we get 20 to 30 people.
But we're celebrating a whole week of septic.
That's right. And it's amazing how many people, all homeowners, really are concerned about how all of this works, and it's something that they don't necessarily fully understand for their own property. So we're looking for other topics of interest like that, and the way that water and streams and rivers work in our communities is one of those important issues. And so what I want to do today is introduce our Vice Chair, Kelly Stadler, who wears many hats. Aside from being on the subcommittee with me, she also runs the Black River Action Team, single-handedly with loads of volunteer supports, and does amazing work along those lines. And Kelly's going to introduce our speaker for this evening.
Thank you, Nancy. So as Nancy said, I'm Kelly Stadler. I live and work in Springfield, Vermont. I have a day job, and then as my sideline, I'm a river superhero. So I do the Black River Action Team, which I started in 2000 doing river cleanups. Then a little later on, we started doing water quality sampling. And eventually we started looking at things like how things get into the river, whether it comes in overland or through a tributary, from a culvert, or from the ground. And it occurred to me in about 2009, 2010, when I first met Kristen Underwood over here. She came down from UVM, I believe it was, and she let me and a bunch of volunteers participate in an assessment of the Black River, and the next year was the North Branch, and we were looking at how rivers move, how they work, how they function, and that they don't just carry water. And sure enough, the following year, everybody learned just what rivers do. So anytime I have a question about what rivers do and how we can all get out of the way and be smarter about how we live alongside them, I turn to Kristen. So I'm very grateful that she's here tonight. We are all very happy to have her. So hopefully we'll all come away with a whole new idea of how to get along with the rivers in our lives. So,
cool.
Thank you for coming, Kristen. Appreciate it.
Thanks for having me. Thank you. Thanks for coming, everybody. I made the drive down a couple hours from Bristol today. It was a gorgeous day along the river on many stretches of the road, so it was a lot of fun. Working with Kelly on the Black River in 2009, 2010, we got to explore some of these topics that we're going to be talking about tonight. I came prepared with a couple key messages for homeowners to take home, for community members to take home, how we might work in our communities toward flood resilience. And feel free to interrupt me as we go along if you have questions or want to raise points. So rivers are very dynamic systems, clearly. They move a lot through space and also through time. Does anyone recognize that location? From the Ottaquiche River in Woodstock, of course. And that's probably taken in August or September, and here is 2011, the same view. How many were here for Tropical Storm Irene? Yeah, most everyone here has gone through it. So rivers are pretty dynamic systems. Clearly, they can go from just low base flow to extreme storm flows in a matter of a couple of hours. And as you can imagine, that poses risks for those of us that live along the river. Rivers move not only water, but also sediment load and large woody debris. You can see there on this laser pointer is not going to work here, but large woody debris and occasionally refrigerators and propane tanks and other items that they may pick up in their travels. We also, it helps us to recognize that rivers carry ice. Particularly at this time of year, rivers can be subject to ice jams, where huge blocks of ice get shed up onto the floodplain and may put at risk residential buildings or other structures that are in the floodplain adjacent to those locations that are prone to ice jams. It's also important to note that rivers carry organic material that's critical for sustaining life in the stream, particularly in the fall when we see the leaf drop. That organic matter falls into the river and it gradually breaks down and is there to provide food and sustenance for fish, which in turn feed the raptors and other critters that live and play along the river.
What is that?
That's an osprey, yeah, with a nice breakfast there in the morning sunlight. And for those of us that spend a lot of time on rivers, I think we know this, but others may not always be aware that along these rivers, many critters use the habitats in stream or along the riparian edges or the riverside edges of the river for their habitat, for their homes. Occasionally, rivers contain humans and kayakers and anglers, of course, and those of us cooling off after a hot summer day. Does anyone know where that famous swimming hole is? That's Bartlett's Falls on the Nehaven River in Bristol, Vermont, actually.
Oh, yes.
My hometown.
It's beautiful.
It's a nice spot to recreate and cool off. We have a long history here in Vermont of developing along our river corridors as well, which can put at risk those homes and commercial buildings that are along the river. Anyone recognize that spot? Also in Tropical Storm Irene. This is in Wilmington, Vermont. It was pretty devastated by the floods.
How did you get there?
Yeah, at the time there was no easy way to get there, for sure. And this was a flooding stage that was similar to that of the 1927 flood. We have in Vermont and other places in the US FEMA floodplain maps that help define for us where we might expect those big storms, those 100-year storms, the floodwaters to rise to, those inundation flooding extents. Unfortunately, those maps are not always suitable for expressing the risk to structures from erosion hazards, where the river may suddenly avulse to the side in a flood overnight and undermine the structures alongside the river. This is a home in Rochester that sustained damages, was a total loss in the Tropical Storm Irene. And by all accounts, according to the FEMA floodplain mapping for rising water flooding, it was safe. It was high and dry, well above the expected elevation for a 100-year storm. But the erosion hazard flooding was not accounted for in those FEMA floodplain maps. And what happened is the river suddenly avulsed to the side during Tropical Storm Irene and undercut or undermined the sediments that underlay the foundation for that building. So here in Vermont, we're starting to recognize that erosion hazards are not always captured in the flood mapping studies, and we're working to account for those erosion hazard areas as well as the inundation hazard areas. Because many of our structures and our land uses and our roads and transportation networks are in close proximity to rivers and occupy the floodplains immediately surrounding the rivers in an area that we might call the river corridor. And that puts at risk our utilities as well as our roads, and can destroy stream crossing structures like bridges and culverts, where when we are impacted by these extreme events. So Vermont found itself in kind of a vicious cycle, particularly in the floods of the 90s that hit the central and the northern part of the state pretty hard, where in response to these big flood events, our tendency was to go into the river and dredge the river, perhaps straighten it, armor the sides of the river, berm along the edges of the river, in order to protect our roads and our buildings that may be occupying the floodplain adjacent to the river. And that's a very costly endeavor. And moreover, it's not always a very effective way of protecting our structures. And we can get into this vicious cycle of repairing after a flood, feeling a certain sense of calm after a big event. Like now we're 8 years past Tropical Storm Irene, and I'm beginning to see around the state of Vermont, and I'm sure John is as well, development creeping back into our floodplains close to the rivers. And that's all well and good for now, but when the next big event comes, those structures will again be at risk of undermining and destruction in the next flood. So given that, early in the 2000s, Mike Klein and Barry Cahoon at the Agency of Natural Resources here in Vermont set about to kind of shift the paradigm, change the way that we think about occupying the land in and around rivers, and give the river more room, essentially. Let's holistically assess our river networks. Let's understand our river systems, how they carry sediment, and where they might need a little more room to move. And if we can step back a little bit and give the river a little more room to find the balance that it needs, then that's probably more sustainable and less costly in the long run if we're not having to continually invest in armoring or other repairs after floods to protect our property in the river corridor. So these three areas are what we might think of as public values in the river corridor. Certainly the river's supporting fish and wildlife. We want good clean water and plenty of good clean water. And we also want to be protective of public safety and property. And at the nexus of those, or the intersection of those, really is this idea that if we can manage our river corridors toward a more balanced state and good connection to floodplains, good floodplain function, then we'll be able to achieve all those public values through our management of rivers and river corridors. So early in the 2000s, Agency of Natural Resources, as I mentioned, Mike Klein and Barry Cahoon, developed a set, along with others, Stacy Pomeroy, Shane Jaquith, developed a set of protocols to holistically assess the rivers and streams in the state of Vermont using the science of fluvial geomorphology. And that's just a mouthful. It really just is a science of the study of rivers. It recognizes how variable our rivers are, ranging from steep slopes in V-shaped valleys to wide open floodplains with slow winding streams through them. And each of those river types has a different sensitivity or propensity for adjusting. Maybe those tiny streams in steep settings and V-shaped valleys don't need a whole lot of room, but these other bigger rivers in wide, unconfined valleys that are slow winders and their natural tendency is to meander, those are the river reaches that we want to give a little more room to. So the science of fluvial geomorphology really is a way to categorize or classify our rivers into reaches of like types. And it's a fancy word, but all it really means is studying how running water processes shape the land surface Fluvial means running water, geo, earth, and morphology is simply the study of shapes. So Agency of Natural Resources set out to develop a set of protocols, phased set of protocols, phase 1, 2, and 3, for stream geomorphic assessment. And the cool thing is, if you're going to set about to do a geomorphic assessment, really what that means is someone wants you, in many cases is even paying you, to walk up and down rivers for a living. It's awesome. So I spent a number of years in the 2000s assessing a number of river reaches around the state of Vermont, including the Black River with Kelly. Basically it's an inventory of the river reach, where we're paying attention to lengths of eroding stream banks, lengths of hard armoring of the banks where perhaps riprap or concrete or gabion walls have been installed. Periodically we stop and make cross-section measurements across the stream to capture the hydraulics, so that we can make predictions about how water and sediment are moved through that stretch of river. We count pebbles. We count at least 100 pebbles at each cross-section in order to get a sense for the size of the material that river is carrying, and what kinds of material might be eroded in the next flood and made available to downstream reaches and perhaps jam downstream culverts or bridges. And essentially we gather all those measurements and metrics together, and we're able to classify our streams into recognizable types. If you're a fluvial geomorphologist, this is your language. This is your short language for river types. You can amaze and wow your friends and say, well, hey, this river is a C4 riffle pool system, if you'd like. We also pay attention as we're walking down the river to the dominant adjustment processes that are ongoing in that river reach. And we have 4 processes that we're looking for. One is degradation or incision, where we see that there's been a down cutting, an incision downward into the bed of the stream to generate or erode materials from the bed. And that's usually signified by undercut banks on both sides, or freshly exposed tree roots or shrub roots. Occasionally there'll be steep riffles or head cuts, what we call sometimes nick points. These are of concern to us because they can actually walk upstream and undermine a structure that might be upstream of us, say a culvert or a bridge abutment, unless they're arrested or stopped by an exposure of bedrock, say, for example. So degradation is one of the processes. The second process we look out for is widening, and that's simply, just as it sounds, the width of the river is becoming wider and wider in response to upstream pressures or stressors. And you can see that by just collapsing banks on either side, or if the edges, the stream sides are vegetated with trees, that you can actually see as you're walking down the river, trees leaning into the channel from both sides. And that's a key or a clue that that stretch of river is undergoing active widening. Another process might be aggradation or building up of the bed. Deposition, fresh deposition of lots of gravels and even cobbles and sands. And usually they're unvegetated, which is a clue to you that they are fairly recent. And they may have steep bar faces. Those are all symptoms of aggradation being an ongoing process of adjustment in that river reach. And finally, the fourth process that we look out for is something called planform adjustment, where river meanders actually move up and down the valley. And we can see this most readily from some historical analysis. We have to go back and look at old photos of the river. And these are becoming more and more available now. You can actually go on Google Earth now, click on there's a little timepiece at the top, and it will send you back in time at least to the 90s, and hopefully they'll begin to add some more historical imagery on there. But you can, for your location, you can click back in time and see how the river looked different over time. And so not every reach of the river will behave in this way. There are certain reaches of rivers that tend to have a very expressive meander profile and exhibit this kind of planform adjustment. And you can imagine those are locations that you want to be very careful about developing around. This, in fact, is a stretch of the river of the New Haven River in Bristol that has moved around quite a bit, and there used to be a mobile home park right on the inside of this bend, and they were all evacuated in the 1998 flood, which was a 500-year event.
All these processes you're going through, are they considered to be like baseline normal, or are they human-induced?
That's a great question. They are normal. They're natural processes, right? And a river over time will undergo all of those processes. Essentially, though, what's considered a stable river or a balanced river in a state of quasi-equilibrium, for that one reach, if you looked over time, it would maintain the same general slope over time, the same general meander pattern. The meanders might shift, but the meander pattern itself would have similar width and length over time. But when we add stressors to our system, if we change the water load to a river, or we change the sediment load, or we change both, or perhaps if we go in and decide to straighten that stretch of meandering river, those are considered stressors that might cause the river to undergo an accelerated rate of those adjustments.
One thing I've heard is that it's really hard to find the rivers nowadays that you can consider like pristine
Or reference state.
Yeah, especially down in the lower reaches. So
yeah, that is to some degree true. There are a number of good or reference reaches around the state that have been assessed, often in more headwater reaches. But it's true that many of our lowland rivers, if you think about where they're placed, there's nice wide valleys, and so those are ideal for agriculture or for development. And so along with those changes to the landscape as well as changes to the river, we have maybe induced some of these processes to be sped up a little bit. And those river reaches can be out of balance to some degree. So all of this fluvial geomorphic assessment data gets synthesized or boiled down into river corridor plans. And for many of our rivers in Vermont, and in this region in particular, rivers have been assessed, and there is a river corridor plan available that you can access online at the DEC's webpage. This in particular is a stretch of the Black River through the towns of Ludlow, Cavendish, Proctorsville. A stretch that I think you were with us on, Kelly.
Is that where we did the pebble count?
It's probably where we did the pebble count. That was a lot of fun. So you can boil down the information from a geomorphic assessment into maps and plans for projects and practices that might help to reconnect the river and support a return to a more balanced or stable form. So based on the current condition of the river and how we expect the river might adjust going forward, we can identify projects or practices that would be suitable. So in this case, in the green, we have reaches that are generally stable in the current state. In orange, we have reaches that are somewhat entrenched. They've undergone a degradation or an incision process, so they've lost some connection to their floodplain. They no longer spill over their banks during a high flood to be able to dissipate the energy of those high floods. Often those orange reaches, those entrenched reaches, are through village areas where we have encroached on the river and filled the floodplain with structures and roads and whatnot. And then other reaches in the red are adjusting laterally. They're undergoing lots of widening, planform adjustment, and aggradation. And we may see conflicts between those adjusting reaches and our nearby structures or roads. At the same time, those actively adjusting reaches are building new floodplains for themselves, essentially. And so to the extent that we can support the river's work in building that new floodplain, we've just gained something for our communities. We've gained an attenuation asset, we call it, a place where the river can spill out over its banks, dissipate the energy of those future flood events. So in this case, we've got the village areas of Ludlow, Proctorsville, and Cavendish positioned right along the river, on the Black River. And where we don't have current conflicts with other property uses, we might seek to locate some attenuation assets, some locations along the river where we can, as a community, think about protecting the river's ability to move and attenuate those flood energies. So a river corridor plan is one place that can outline some of those projects. So when I was asked to come, I think the main question Kelly asked was, can you come and give us some ideas about what we might do as homeowners and community members to work toward more flood resilient communities? And so I have three main takeaways, one of which could be know your backyard river. And you may not live on a river, but by backyard river I mean your local river, where you go to recreate, where you go to play. So you can know what stream type it is and how prone it is to adjustment by reference to a river corridor plan and geomorphic data that's online, if you like. There's a cool tool called Usgs Stream Stats where you can actually delineate the upstream watershed that drains to your area. So if you Google USGS Stream Stats, it's available for all of the United States, but you can zoom into your location, find your river, click on it, and this program will delineate for you the upstream watershed draining to your point of interest. So if you're ever curious, it's a fairly straightforward procedure. You can know your backyard river by volunteering for your local watershed group like Black River Action Team and get to go out on the river, collect some water samples, know the quality of the water that's flowing in your favorite stream, in your backyard river. Secondly, I would say it's really helpful for us as community members to look for opportunities to reconnect our rivers to their floodplains and also reconnect our rivers upstream to downstream. And what I mean by that is if you can picture a river, river systems work best when they are well connected to their surrounding landscape, either laterally across the floodplain or longitudinally upstream to downstream. If we've blocked rivers with dams, with bridge or culvert crossings, that has an impact on the connectivity of the river and also on the ability for fish, for example, to swim upstream or swim downstream, and even for land-based creatures like bears and whatnot for going upstream and downstream. So in your region here, I know that in West Windsor there was a recent project to remove the Millbrook Dam. That was funded by the High Meadows Fund, and I think that's been completed. So that's one example, and what they anticipate is that by removing this underused and no longer used dam, the properties immediately upstream will be saved from future flood impacts. Another way that we can longitudinally or upstream to downstream reconnect our rivers is by replacing undersized stream crossings that also block the passage of fish and creatures. I know there have been a number of projects implemented in this area. Often there's funding through U.S. Fish and Wildlife and other sources. Trout Unlimited, I know you had a speaker here not too long ago from them. In Bristol, for example, we reconnected our New Haven River laterally. We reconnected it to its floodplain through a couple of projects known as river corridor easements. This was a stretch of the river on the Bristol Flats. In fact, this bend in the river had grown since the 1998 flood, when the riparian buffer was stripped off by that big flood event. And that main meander bend there grew over the space of about 5 years, and the farmers lost about 5 acres of topsoil downstream. We, through a series of kitchen table meetings and by piecing together funding from a variety of public and private sources, we implemented a project here to protect the river corridor, which you can see hopefully outlined in that fine red line to either side of the river. And compensated the landowner, one of the landowners, for lands taken out of agricultural production through a conservation reserve program, USDA program, and also some agency of ag funding from the state of Vermont. One of the 2 river corridor easement parcels have since been turned over or donated to the town of Bristol, and this now provides public access for our community to the river for anglers and boaters. And we implemented some language in our local planning and zoning that would strengthen the protections for similar river corridor projects along the river. And essentially, this is that floodplain attenuation asset for our community. It's like a very inexpensive stormwater treatment system, if you want to think of it in that way. It was in the tens of thousands of dollars to accomplish this protection for the river, and it has gained the community probably the equivalent of $1 million or $1.5 million in stormwater attenuation, if you want to think of it in that way. Associated with that, of course, and this is another great way to get involved in reconnecting your rivers locally, planting buffers where we have buffer gaps. It's an easy project. Kids love to do it, students love to do it. This is the Middlebury College ski team that's helping us on the New Haven River on a sunny May, it was almost sunny, May Sunday. And that area now is fully vegetated and helping to stabilize the bend in the New Haven River.
Is that willow that you're using?
It is willow there, for sure, yep. These are, it's a rugged species, really. You can you can go and cut it at a local source on your river and bring those live stakes, they call them, and set them on your planting site, and they'll sprout within a couple of months. In fact, we were, this was in May, and by the following May, most all of the live stakes had sprouted, and we had 2 to 3 foot high willows along here. Today, if you go back, the willows are about this tall above your head.
Do you have to maintain them at all?
We did not maintain them at all. We did not water them. We did plant a number of trees along this buffer, and we had a dry summer follow that, and unfortunately we lost many of the saplings to that dry summer because we just couldn't get out there and water them all the time. But the willows survived very well. And what these are on the top left, that's a willow wattle. These are just lengths of willow whips that are bound together, and you plant them in a shallow trench, and they themselves will also sprout. So you run one length parallel to the stream, and then you have like spokes of a wheel. You have other wattles pointing toward the river, and that's a pretty effective way, pretty dense root structure to hold the bank.
You have a nursery for that willow?
We did not have a nursery for the willow. The kind volunteers from the Middlebury College alpine ski team and their coach, Steve Bartlett, was just on top of the willow. He just went out on a couple of Saturdays and harvested lots of willow, bound them up, and we kept them in the cooler at the at the NRCD offices, Otter Creek NRCD offices, for a couple of weeks until we were ready to plant them.
So they love water, so you
They
cannot
love
put
water.
them near a well or a septic system
True.
or a stone wall.
True, exactly.
Growing
You
all
do
over.
have to be very careful about
Near river, they're
what you
not
plant
allowed.
and where, yeah, that's for sure. This particular site is at least 1,000 yards from the nearest home, so. But it's a great active project. It also provides shading for the river, for fish habitat, organic material to help sustain life. And this particular project, I could have given you a whole presentation on just this particular project where we installed root wads here along the outside of the bend in order to stabilize the bend. And those are basically white pine trees that if you fall them and leave their root ball intact, that's called a root wad, and you can truck them to the site. Basically you cut the tree so that you have about 20 feet of trunk above the root ball, and then you sharpen the end of the trunk. And these, because we had the potential for archaeological remains in this area, we could not dig trenches to lay these root wads. We had to push them in about 3 feet below the bank using an excavator. And we pushed them in until we met refusal and then backfilled a little bit. But those root wads are still intact. They stabilize the bank just like riprap would, big blocks of stone. But the advantage of these is that they create great pools of habitat underneath them for fish. On the upstream side, they capture sediment. So there's a lot of diversity of the bed here, which is great for fish habitat, but they're just as effective as stone at stabilizing the bank and keeping that cut bank from eroding further. So that whole system is intact today. We have like essentially it's protecting a new area of floodplain for the New Haven River.
How long do those root wads last? I mean,
They will eventually rot,
decompose.
right?
Yeah.
But white pine in water lasts
For a long
long
time.
time.
Exactly, yeah.
I-
And they have much greater habitat benefits for the river than does, big chunks of white marble, say.
Yeah, I just wanted to add that I went and visited a project in Orford where they were talking about trees into streams. It's starting to be more widely, I have a whole book on this at home, so I've been
Cool.
reading about it for years, but about how wood in streams is like the very start of the food chain.
Yeah.
Work up from the bacteria to the tiny little scrapers to the, finally up to things that trout eat.
Yep.
And
Yeah.
so wood, I mean, comparing wood to riprap, it's like wood is living, it's
Right.
the basis of life, and
Right.
rock is just rock.
Rock is just rock.
Well, I mean, that rock we use for riprap just looks like it's just, so bare.
Yeah. Yeah.
I mean, they do that. I'm hoping the Army Corps will come around someday and realize they don't have to line all their reservoirs with just bare rocks.
Yeah. Definitely wood has a role to play when it comes to stabilizing banks and enhancing the habitat along our stream sides, for sure. So the last thing I would just say is that we can all engage in our local planning and zoning to include strategies for avoiding and mitigating flood losses. So these slides are from Mike Klein at A&R, and they're a couple years old, but we do have 77 at least, probably more by now, of the 251 towns in the state with river corridor or enhanced floodplain bylaws in their zoning that help afford additional protections for riverside property. 45 communities have completed river corridor floodplain restoration projects, which run the gamut. And 90 river corridor easement projects have been implemented around the state. And I think one of those dots is on Bristol in that project that I showed you. So there are opportunities within our local boards and commissions for us to be mindful of these river corridor protections as well. I think with that, I'll take questions and welcome your thoughts on any of this. Yeah.
Um, we did a lot of work trying to work with dam owners for Wilder and trying to
Okay.
trying to get them to see, you know, what could they do to at least help in offsetting some of the impacts of the dams along the Vermont and New Hampshire sets of the Connecticut, but also conscious of the tributaries and the impact on the tributaries into the Connecticut, and wanted to know what your thoughts were on, like, the Black River, for example. You know, what can be done to help support or offset, because the chances of we aren't getting anywhere with the dam owners in terms of helping us to do projects and erosion related things. I mean, they're looking on purely commercial, more short-term basis. So anything that we could think about that would assist, perhaps not the Connecticut because of the scope, but what the tributaries, what to look out for, how will the dam be affecting the actual structures.
Sure. Yeah, so I think I teach a class at UVM, and I jokingly say to them that if you are not certain of the answer to any question, just say, it depends. Because it's so much of our environmental work really depends on the circumstances. So not all dams are bad, but dams aren't bad or good. They just are. And certain dams are suitable for removal because they're underutilized, they have no longer any purpose, and those are kind of low-hanging fruit projects for removal in order to reconnect our rivers. Other dams may have very important roles and provide public services like hydropower, here along the Connecticut River, flood control. So Tropical Storm Irene was not nearly as devastating as the floods of the 30s or the 1927 because of the flood control dams that were in place up and down the Connecticut River and the tributaries to the Connecticut River. So every situation is different, and it has to be evaluated in its own context for the values that are provided, both to us as humans and society, to the habitat. And there are ways to mitigate the impacts of dams, such as fish ladders, such as operating dams, like I think it's down in the West River where they do an occasional release from the dam in order to mimic the natural flow cycles of rivers in order to, for the benefit of habitat along the river. So I think there are opportunities to mitigate some of the impacts, and not knowing the specifics of the dams and the tributaries you're talking about, I would hesitate to offer any specific recommendations, but certainly there are things we can do.
Right.
I don't know if that answers your question, but
yeah, it's kind of, you know, because the cost of removing the dams, even the ones that have been deemed to be,
right,
you know, sort of.
And these are dams that are no longer used, or
pretty
okay,
much,
okay.
yeah.
So then you get into, it is a costly endeavor, but there are funds available, public-private partnerships of funds that can afford these things. And I would encourage you to talk to State of Vermont about those, or let's see, there's Trout Unlimited is a great partner in some of those projects. And there are others that are not coming to my mind, but I can definitely forward you some
I think
links.
one of the things that we ran into is people don't always understand, well, what's the benefit to removing it? What's the
Right.
benefit to
Right.
leaving it in place? And people on both sides
Yeah.
think that there's a benefit either way, and it's trying to make that case for removal where appropriate, and,
Yeah.
and what the benefits of that are going to be when people are used to having it
Right.
the way it is.
And there are some great techniques available to kind of visualize what it will look like before
Okay.
and after, photo techniques. I would encourage this group, if you are thinking about future speakers, Roy Schiff at Milona McBroom will give you a great presentation on a dam removal project they did in East Burke, northern Vermont, and where they did that. They had folks in town that really were hesitant at all to think about removing the dam because of its historical value, its cultural value, and so they went through a very public process early on in that project to help folks understand the pros and the cons and visualize what it might look like before and after and so forth. And it was a very effective project. It's just been completed in the last year, I think. So he would give a great talk on that if that was of interest.
Okay,
Yeah.
that'd be great.
And there were a couple other questions. Yeah.
I've used the stream table with school kids.
Yeah.
I'm in West Windsor, and we had the two dams there, the one
Oh, good.
on the Millbrook, the old stone one, and the one behind the fire station. And I've been doing work on the river for years, and it's really amazed me that there's been progress. You know, but I had given up, you know, even though I kept banging away at it. But in the stream table, I would give the kids the challenge to try and make that river work with that dam, particularly behind the fire station where we had all the flooding. And they would try all kinds of permutations, and you could not make that river work with that dam in there. I thought that was kind of an effective learning opportunity.
The stream tables are really great for helping to visualize the problem for sure. And that particular, in the West Windsor, there's a great link to, if you go to freevermontrivers.org, there's a video that kind of walks you through this project in particular.
Oh, really?
And some of the pros and cons there. They interview the construction folks and the homeowner as well, closest, the dam owner, I guess.
So that's the link.
This link right here on the bottom is or if you Google probably Millbrook Dam removal, the title of it is Adapting Changed Climate Dams Flooding. If you Google that, maybe it'll pop up. It's a YouTube video.
If you wrote down your email, probably share the slides.
Okay.
Exactly.
Oh, that would be great.
Send you.
Yeah.
You can see it.
There's another question here.
Yeah, I'm trying to figure out how to word this. I hope it's not going to be just, it depends.
That's my go-to answer. I tell you. It works for professors as well as students. So
I'm always trying to look at things as holistically as possible. Watersheds, for instance. We've been talking about river corridors here. For quite a while, I've been really interested in looking beyond river corridors. In fact, I mean, we started a whole organization about that. So my question is, I'm always trying to figure out who's in charge of these various aspects. I know you are officially a fluvial geomorphologist, is that right? Okay, so I understand now you study flowing water and stream forms. Okay.
Yeah.
But then you go up in the farthest reaches of the watershed, and you have wetlands, you have forests, you have, and water's everywhere, as we know.
It's all connected.
It's all connected, exactly. That's what I mean by holistic. So how in the world do you come up with plans? I mean, it seems like you need to take into account, just as an aside, I always heard that, for instance, Middlebury was largely spared from Hurricane Irene because of their extensive wetlands upstream from the town.
Definitely.
So apparently, that got quite a bit of attention.
Yeah.
So how do you, I guess my question is, how do you account for the effect of wetlands eventually on stream dynamics? Because obviously they're holding back the volume of water, and letting it trickle more slowly. And that goes for all landscapes. Of course, there are supposed to be vegetated ones that are slowly releasing it rather than inundating with stormwater. So
in the case of Middlebury, those wetlands were very closely connected to the river. So the river spilled out over its banks and connected right away to a series of wetland complexes that were adjacent to the river.
But the question is, when you do these assessments, so, I mean, are you doing assessments that just sort of cover the whole state, not just the river corridors? So
Not quite the whole state, but within a
Well, I
corridor.
mean, you know, these areas, not, you know, blocks rather than just
Sure.
corridors.
So the assessment protocols proceed from phase 1, 2 to 3. And phase 1 is a very desktop-oriented assessment where we're actually looking at the whole watershed, essentially, and the soils that make up the watershed, the land cover, the land use within that watershed, and how those factors may influence.
Is that something we can all look
flow.
at?
Yeah, if you Google Stream Geomorphic Assessment Vermont, you'll come to a page that will have these protocols listed.
Okay, and one thing you need to keep in mind is that this group is half New Hampshire,
Yes,
so.
I'm glad that you raised that because these protocols are being used in New Hampshire in large part. Their program as well has adopted these assessment protocols.
Do we have the maps of the, you know, all these maps that show our area? Like, before you mentioned this, what was this one about?
Oh, the stream stats?
The stream stats, I guess that's the whole country, but.
That is the whole country.
Yeah.
So that particular map here is a New Hampshire watershed, in fact. It's the other Millbrook, the Millbrook in New Hampshire.
Oh, there's loads of them.
And so, stream stats is available for all of the U.S.
Okay, but what about the general water, that one you showed us, this phase 1, that was for Vermont?
Yeah, the protocols were written in Vermont and are used in Vermont, but they're also being used in New Hampshire and other states, by the way, to some degree. So,
But can we look up a map in New Hampshire? I mean,
Oh,
I'm
I see what you're
aware,
saying.
You know, we can look up
Yeah.
things like compared streams and.
yeah, in Vermont, you can go to a page that has I know, that has all the watersheds, and there's a couple of New Hampshire watersheds in there, but New
Oh.
Hampshire has its own web-based system, which is very analogous to the Vermont system, and you can view some of the results for the New Hampshire-based assessments, or I don't know, I haven't been on there recently to know how well populated that table is. I don't know if you have, John, but.
Okay.
So they're in New Hampshire, I would say they're a little farther behind than we are in terms of having all of these quarter plans and assessment data available, but they are working toward that. So at some point, this region, for the towns in your group here, there should be some
Well,
data
in New
available.
Hampshire, you know, what they call wetlands, they have their wetlands bureau, but they cover everything. You know,
Yeah,
anything that's wet, it doesn't have to.
right, different states approach these
It's kind of an odd.
in different ways, yeah.
Term they use, wetlands, yeah.
Yeah. Questions? Okay.
Mine was, this one's about more to do with the riparian buffers and the
Mhm.
role of the riparian buffers.
Sure.
I know Kelly's done some projects and we've looked at a number as well, in terms of how to convince sort of local folks the value of the riparian buffers when what they want to do is cut mow
Mm-hmm.
straight to the edge
Yep.
so that they have the best view.
Sure.
And you start talking to them about planting trees,
Yeah.
and they start to say, well, I bought this place so that I had a view
Of the river.
of the river.
Mm.
And though you can sometimes convince people, yeah, but you're downriver of somebody who, if they clear cut
Right.
their banks, would lead to possibly problems and erosion
Mhm,
that affects you. So it's kind of, you can't beggar your neighbor because you might be that neighbor
Sure.
on the other side. And I just wondered what your, when you're teaching it or when you're talking to different groups, how you position the
Sure.
importance and.
Yeah, I mean, it's an individual choice, right? And certainly you can't force someone who doesn't want to plant, but all I can say is that I know that trees or shrubs, if they can stabilize the bank, then that will protect their property. They'll lose less of their property downstream, perhaps, in a future flood. And as you raised as well, they may be a source for sediment and debris to their downstream neighbor. And so planting to stabilize a riparian buffer will help not only their property, but maybe protect their downstream neighbor's property as well. There's ways to go about it where you can still preserve a path or a view, a smaller view perhaps, and kind of have the best of both worlds, some stability from new plantings, but also some gaps in that buffer where you can enjoy your time next to the river. But it's ultimately it is an individual choice.
What about low shrubbery, isn't that better than grass? I mean, it's.
Yes, it's better than grass, for sure. The shrubbery would have a little deeper root system that would help to stabilize the soils in the
They can
bank.
still see over that maybe.
Yeah.
If they do nothing, they'll get the real close-up view of the river.
They might get a real close-up view, it's true. Was there a question here? Yeah.
I was curious about culverts, and I know they're especially when they're undersized, especially harmful for aquatic species and a lot of species. But I'm curious for flooding, how impactful they are.
Yeah.
Like I know they are impactful, but I'm curious like what degree they can kind of impact the landscape and.
Yeah. So a culvert like this that's quite undersized certainly is an impediment for fish passage, but it also on the upstream side, here we're looking at the downstream side, on the upstream side during a flood, they can more easily jam with large woody debris carried from upstream. And when they do jam, then the floodwaters have nowhere to go except up and over the road, and usually they wash out the road oftentimes, or at least the approaches to the crossing. So they can be fairly destabilizing. In fact, in the Forest Service spent quite a lot of effort replacing their undersized culverts and structures with much wider arch structures or sunken culverts that had a natural stream bed before Tropical Storm Irene. And it turns out that so those culverts were matched to equal or exceed the bankful width of the river where they were set, and they survived Irene, while the undersized culverts did not in those same regions. So it was a real testament for not only the value of these kinds of retrofits or replacements for aquatic organism passage, but also for flood resiliency, really. The wider structures can be a little bit more expensive, usually are, but if you're not having to replace them every 15 years with a big event, then over time they can actually pay for themselves. And so that's why we now have regulations on the books in the state of Vermont that new structures that are installed or replacing older structures have to at least meet the bankful width of the stream. It makes sense for aquatic organism passage, but it's also a public safety issue, really. Those structures will be less likely to jam and catastrophically fail in a future flood event. So,
Isn't it more economical to do this ahead of time instead of waiting until the blooming thing has washed itself out? I know
yes,
Heartland spent
often.
almost $500,000 on one culvert, on one back road.
Yeah, they're very expensive for sure.
Extremely so. After.
And it would be less costly ultimately to proactively set about or go about replacing. But unfortunately, that's not usually the way the economics work, and often we are reliant on the FEMA dollars that help contribute to replacing structures after a failure.
But
And
FEMA only pays for replacing like with like.
not any longer, actually.
Really?
Through as a result of Tropical Storm Irene, and maybe John has more background on this, but as a result of our efforts after Tropical Storm Irene, Vermont lobbied with FEMA to allow us to replace structures with wider, and won that argument. And so now that's
They're paying full freight.
well, now now you're able to they will pay for a structure to be, a wider structure to be put in place.
They will pay their share.
Their
for
share.
A wider structure. to
Their
be-
share.
for
And usually it's like
infrastructure.
80-20,
75.
75-25.
75%. Local town is up to you, depending on how resilient you are.
Exactly, exactly. So that was a,
I'd like to put in a good word about the stream tables.
oh yes,
Besides being a rep to this committee, I'm also a volunteer supervisor for the Ottaquiche NRCD.
cool.
And after Irene, we got acquainted with stream tables and we started acquiring them. We now have 2. And they go to the schools.
That's
And
good.
next month, they will be at the Flavors of the Valley at Hartford High School. So
Okay.
that's a good opportunity to see the stream table.
They're really
yet
fun.
Once more. And
It's-
it's also a lot of fun to go to Flavors of the Valley.
And they also, I think, came to Windsor or this area with the road crews. We got
Yes.
them together with the road crews. We felt it was important that they understand how they function and how the rivers function. And I think teaching kids and teaching the public with those stream tables is incredible. I saw them first up at the State House in Montpelier, and it just gave a whole new meaning to me, an understanding of water. And granted, if somebody gave me this beautiful piece of land, you know, right on the river, I'd pull back and I'd build the house up like this on big stilts and lots of stuff underneath, lots of green stuff underneath. So, I mean, I just think, you know, the stream tables are really incredible
Definitely.
learning tool.
That's right, Donna. We did have it out for the road crews.
Right.
We had it out for the people that run the backhoes
Mhm.
and tell them, you know, you don't have to go excavate down in the
Right,
river.
don't dig deeper.
There's
deeper,
other
deeper.
ways you can
Right, right.
make a living that will be more beneficial to your river.
Yeah, exactly.
Yeah, but one of the other critical things about sizing the culverts too is now that we're seeing shorter duration, higher intensity storms.
Yes.
I know the area that I worked in, they defined a 100-year storm as 6 inches of rain in 24 hours.
Mm-hmm.
We had a storm, we got 5 inches of rain in a half hour.
Mm.
Exactly.
And it completely
Really intense.
wiped out storms that would have taken a 100-year storm without any problem.
Right.
But, you know, the engineered standards that they're using for, you know, a certain size culvert for a certain year storm
Right.
is just way out of touch with what we're seeing today.
And we're seeing an increasing trend in those high magnitude events. So it's when it can be afforded, it's better to size a structure larger. Yeah. Cool. Well, thanks so much for having me
Thank you.
down today. And I'll send you the slides.
Yes, we definitely would like the
A copy of the
copy of the
slides.
slides.
Okay.